Hi guys, Mark here from HarwellXPS and I'm back with another look at curve fitting. For those of you that haven't been keeping up with the releases of curve fitting from Gwilherm Kerherve, there's been loads of new features added recently. It's looking better than ever and it's available completely free. If you go to SourceForge, search for curve fitting and you can download the latest version now. He's still updating it, adding new features all the time. But it's looking great. So we wanted to get back in and starting to produce some more support videos, help get more people using it, get more people understanding how everything works. And so today we're going to be looking at a couple of the newer features in KherveFitting, which is looking at peak identification from a survey. So trying to understand what you've got in your sample, what kind of what all the peaks mean, and where they come from, what elements you've got, that kind of thing. And we're going to hopefully help you to get started in using curve fitting as a super user. So let's dive in. Okay, so I've just loaded up some palladium metal and we're just looking at the survey for now. We've got quite a few peaks in there and we're going to try and use curve fitting to understand exactly what we've got, make sure that we know what is in our sample, make sure we're not seeing any peaks that we shouldn't be seeing. So when you're trying to understand what's in your material, what's in your spectra, the identification tools are all in this part of the main toolbar up here in the top right of the toolbar. There's a couple of different options, so we'll just go through them in order. The first one here with the ID with a little lightning bolt. So this is relatively new. This is an automatic element identification tool. So this is pretty useful, and you can kind of run this, and curve fitting will go through your spectrum and try and identify exactly what's in there. So we're just going to try and run this and see what it picks up, what it thinks is in there, without us kind of giving it any other prompts, and see what kind of job it does. So if you just click on run, you will get a bunch of peaks that it thinks might be in there, as well as a table. And so curve fitting will automatically kind of put these fits in for you and give you a survey spectrum, kind of similar to the auto ID function in HarwellXPS for those of you that have used that in the past. But much like HarwellXPS, you will probably notice that it's probably not done a particularly good job at identifying what's in our sample here. So curve fitting does assign a confidence interval. Obviously you'd like green, above 90 for your confidence, but here, you know, it's kind of picked out a couple of things that, yeah, okay, like the magnesium 1s, there is some kind of peak there, but it's probably not a magnesium 1s peak. We can't see any other magnesium peaks in there. This is probably some kind of peak from the OJ structure of that palladium MNN OJ. Similarly with the NA1S, okay, yes, there's probably something there, but even the actual fitting's done a particularly strange job at trying to figure out what's in here. And if we come over here, it's decided that yes, we've got some oxygen 1s in there. Actually, this is going to be the palladium 3P peak rather than the oxygen 1s. So just by itself, it's probably not done an amazing job. So we can just delete everything that we've put in, start again. Now, one of the reasons I chose this particular spectrum is because it's quite noisy. It's just a single scan, some clean palladium metal foil, but then the signal to noise isn't amazing. So this is the kind of spectrum where you might get some maybe unknown peaks. If you've got a really strong signal, a really good signal to noise, probably curve fitting will do a much better job at identifying what is a peak and what isn't. But for things like this, where we've got just a little bit of noise here and there, we just wanted to show that you maybe need to be a little bit careful about trusting exactly what curve fitting will give you, and it's exactly the same in HarwellXPS as well. One thing we can do to get rid of some of these false positives is to use this percentage function. So percentage of max peak, essentially it's just a measure of signal to noise. The bigger this percentage is, the bigger that the peak will need to be before curve fitting will decide, yeah, okay, this is something genuine. So I'm going to set this to 5 and see what curve fitting suggests this time. So if we click run again, now this time we've got rid of all of those small peaks that were not actually really there. So things like the sodium 1s, the magnesium 1s, these were just noise, and we kind of got rid of everything else. It is still suggesting that we've got a couple of potential options. So germanium, it thinks, is one of the options, and again this palladium 3p peak here, it thinks is oxygen 1s. So okay, we now need to think, is there anything else that we can do to try and convince curve fitting that we have the peaks that we actually do have? So I'm just going to delete all of these again, and then this time in this box up here we can also tell curve fitting that we definitely have some elements in there. So I'm just going to put palladium in here, and I'm also going to put carbon as well. There's a very small carbon peak down there, so we can probably change this to maybe 2% so that it can more easily identify that carbon peak. And I'm just going to click run again. So it's picked up the carbon, and now it's picking up that palladium peak in the 3D and is correctly identifying the palladium 3p instead of thinking that it's oxygen. So it's very useful, this tool, and absolutely go ahead and play with it, but just use a little bit of caution. It's still going to need your input, your assessment, to make sure it's not doing anything silly, like picking up elements that definitely shouldn't be there. So as always, it's very useful to have a bit of an idea about what's in your sample going into this. If you're going in completely blind, then it's going to be more difficult, but in this case we know that there's palladium there, so we can kind of tell curve fitting that we do have palladium in there. So that's the first thing that we're going to look at, and next we're going to look at more manual addition of peaks and peak markers. Okay, so the second toolbar we're going to be looking at is this option up here. It just says ID. So click on that to open the survey, identification and labeling. Now for this, again, it's very useful to have a bit of an idea about what is in your sample, what's going on with your sample, because we're just bringing up a periodic table. And here we can kind of have a look at what potential options we've got. If you hover your mouse over an element, you can see that it will bring up some of the energies of the core orbitals involved. So for example, we're looking here at peaking around 340-ish electron volts, the major emission in this wide spectrum. So if we hover over the palladium icon in the periodic table, this brings up a little bit of information at the top here. And if we click on this, we're given a list of all the possible emissions or the possible orbitals in a survey spectrum. So we can start to kind of add these, and you'll see at the bottom of our spectrum some red lines have been added, which will give you the position of each of these peaks. So you can kind of click on that element and see, yeah, I should be expecting peaks here, 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 and here, and yeah, this matches up with what I expect, or this doesn't match up. So you can also change the line intensity with this little option down here. So if you've got a particularly small peak, so for example here our palladium 4s peak is pretty low, the cross sections on the 4s are much lower than the 3D, so the peak's going to be a lot smaller, and if you're just struggling to see exactly where the marker's coming and does it really line up with your peak, you can change the intensity of those lines here and change them back down if you want to, for when you're exporting these images for presentation or a report or so on. So we can actually add permanent labels to our spectrum as well. So I'm going to pick all of these peaks down to the MNN. I'm not going to go any further because this is a spectrum from an aluminium X-ray source, so we don't have a high enough excitation energy to see the LMM, the 2P or the 2S, so we can leave this here. And then if we click on add labels, that's just going to stick a little annotation next to all of these peaks here. So that again, if you want to create a quick image for a presentation, a talk, or a report or something, you can just add these labels in KherveFitting and export that image as you like. If we click Palladium again, we can remove those peak the line markers, and we're just left with the blue peak markers themselves. So as well as Palladium, I'm just going to clear this list here. Once you clear, we've already had the labels, so if we clear the list, it doesn't particularly matter. But we know that we've got a little bit of carbon there. This isn't a completely clean Palladium foil. So I'm just going to click on the carbon again, and we'll add that carbon 1s peak marker label as well. I won't add the KLL because we can see this region is pretty heavily dominated by the Palladium MNN OJ, so probably we can't actually see any of that carbon OJ there because the carbon peak is quite small. So just to make things a little bit more clear, we'll leave the carbon KLL marker off. But you can go through each of the elements that you think that you might have and slowly add them in. If you are completely if you've got peaks that you're completely unsure of, then you can always use that automatic ID to kind of get an idea about what it might be, and then come into the survey identification and labeling and have a really good model through of what all of those peaks might be. So you can kind of use them in combination as quite a useful tool. So there's one other feature that again is quite new that I absolutely definitely recommend you have a look at and have a play with, which is the third of these options, which is this KherveDB database. Now, Gwilherm has put a tagline on the window here, how I wish NIST would look like, and he's absolutely right. I mean, he's done a fantastic job of giving an easily searchable database here. So we've just got a periodic table, all the different elements, and say, so we've got Palladium, so we might as well start with Palladium. If we click on Palladium, you can see now that this table down here has been populated with a lot of energies for different orbitals, along with an appropriate citation, which has been, I guess, scraped from the NIST database, but it's a fantastic tool to have built into your analysis software. You've got a really, really quick reference point for not only different elements but also different chemical states. So we can go to select an XPS line here, and we're just gonna, let's just limit this to Palladium 3D, and we've got something now that we can click through and look at all of these different binding energies and get an idea about what might potentially be the chemical state as well as the elements within our sample. Now we'll probably do a bit more of a deep dive on this at some point. As with anything, definitely use with caution. It's a fantastic tool, but there's no information here about how the experiments were originally performed. We don't know anything about the charge referencing. We don't know anything about what excitation source was used, what the instrument was calibrated to, etc., etc. So very, very useful guide, and very, very grateful that Gwilherm's put this together. And I'm sure he will tell you exactly the same thing. Great tool, use with caution. Don't just go around and say, I've got a peak at 33.7. This is exactly what this should be. You still need to kind of use your analytical tools, your analytical senses, to make sure that you are you're not mislabeling, you're not misidentifying anything. But as a guide, absolutely fantastic. So big thanks to Gwilherm for introducing this. And if we go into one of our high resolution peaks, I'm just going to open this one again. So here we've quite clearly got some asymmetric peaks, and we can just click on some of our potential species here and identify what this might be. So this is actually a really nice example of why you should always use caution with databases like this, and this is absolutely not limited to the database in KherveFitting, the KherveDB library. This is all kinds of references. So if we look down here, we've got some peaks that have been recorded for the Palladium 3D at about what, 335.1 EV. The first lines we see in our database give us a Palladium metal binding energy of around 334.1 EV. So immediately we're thinking, okay, so we're about 1 EV higher. The peaks look a bit asymmetric, but I guess it can't be metal because we're 1 EV higher. If we scroll down here, we then start to find lots and lots more entries for Palladium 335, 335.08, 335.1. So this database is just a completely scraped table from the NIST database, which contains lots and lots and lots of measurements from over the years. But again, we don't know anything about the experimental conditions, the instrument calibration, etc., etc. So very useful tool, but again, always use with caution. If you know your binding energy, for example, here is telling us we've got PDO, but we don't have any oxygen 1s in our survey spectrum, probably not got PDO. We've probably made some kind of mistake in the identification of this binding energy here. And so this is not something that's limited to this particular application. This is probably something that you see that's more ubiquitous in XPS analysis in general. But once again, it's just something to remember when you're using these tools, to use them as a guide. Maybe don't use them as a as an absolute, this is definitely the answer. But a great feature, and again, thanks to Gwilherm for introducing this. It's going to be very useful when looking for references, looking for potential identities of chemical states. So that's it for this first video back. We're going to be back soon with a more regular release of curve fitting support videos. They're most likely going to go live on the HarwellXPS GURU site before they're released on YouTube. So do check out, I'll put a link into the GURU Resource Center below. If you haven't visited already, we've started adding some guides and some help centers there in collaboration with Gwilherm. So check that out and keep an eye out for the next load of videos on curve fitting. Fantastic tool, can't recommend it enough, and we'll see you soon. Thanks for watching.